Hi, Math. I'm Andy. So let's say that there are 15 animals in a barn. Some of the animals are chickens, some of the animals are pigs, and there are 50 legs total. We want to know how many of each animal. Well, in some ways it doesn't seem possible because there could be 10 chickens and 5 pigs, there could be 7 chickens and 8 pigs, there could be 15 chickens and no pigs. So that this doesn't give us enough information. And then 50 legs. Well, I don't know how many pigs or chickens there are if I just know that there are 50 legs because both chickens and pigs have legs. So we have to kind of think about this in two different ways. We need to create a system of equations to help us figure that out. Now, a system of equations is really just two or more equations that use the same variable. So that's our plan. We're going to do a system of equations. Now, I'm going to come up with two different equations in order to solve this. One equation is going to be about the animals, and one equation is going to be about the number of legs. And with those two equations, we'll figure it out because in both cases, animals and legs, we have the same unknowns. We don't know how many chickens there are, so I'm going to use the variable c to represent chickens. And I don't know how many pigs there are, so I'm going to use the letter p to represent pigs. So with animals, I know that there are some chickens, and I know that there are some pigs, and I know when I add the chicken and the pigs together, there are a total of 15 animals. So we're relating chicken and pigs with the number of animals. Now I also know that chickens have 2 legs generally. So if I multiply the number of chickens by 2, that'll tell me the number of chicken legs. I also know that pigs have 4 legs. And so if I multiply the number of pigs times 4, that'll tell me how many pig legs I had. And if I add up chicken legs plus pig legs, I'm going to have a total of 50 legs. So again, we created two equations that have the same variables, and through our methods of substitution or elimination, we're going to be able to solve this. Now, I think I'm going to use the technique of elimination in order to solve this. Now, elimination, in a sense, takes both of the equations and adds them together in the hopes that one of your equations or one of your variables will cancel out. So in order to do that, I'm going to take everything in the animal equation and I'm going to times it by a value of -2. And watch what happens. -2 times c is -2c. -2 times p is -2p. And -2 times 15 is -30. So I just took this equation and in a sense I rewrote it as this equation, because if I now add these two equations together, 2c plus -2c is 0c. So in a sense, I've eliminated the chickens. Now 4p plus -2p is 2p, and 50 plus -30 is 20. So I'm left with an equation that says 2p equals 20. Now, solving for p, I'm going to divide by 2 on both sides, use the division property of equality, and it turns out that p is equal to 10. So this tells me that p, the number of pigs, is 10. I have 10 pigs. So I need to figure out the number of chickens. I can go back to my equation about animals, and if I know that the number of chickens plus the number of pigs equals 15, I can say there are 10 pigs and subtract 10 on both sides, and I know that that means there are 5 chickens. So in my barn of 15 animals, I have 5 chickens and 10 pigs. And I know that 5 times 2 is 10, 4 times 10 is 50, and so 10 chicken legs plus 40 pig legs is equal to 50 total legs. We just did a system of equations and we solved it using the technique called elimination.